Hello everyone. The topic Today's topic is alloying of steel. In this alloying of steel, we'll learn how to manufacture of steel. There are few steps. Like we may get to know how the steels are manufactured in other industries or what are the equipment they are using. Like what are the metals they are using of to manufacture these alloying of steel. Um, Manufacturing of steel and pin iron, which is the raw material needed to make steel. It is the raw material needed to make a steel, and it is then processed with coke in the absence of air, in the containing the carbon and the limestone or the burnt lime, which are added to the blast furnace at intervals, making the process continuous. The process of the coke in the absence of air, like adding the limestone or the burnt lime, it's added to the blast furnace at intervals and is making the process continuous. Even the limestone or the burnt lime, which helps to remove the impurities on the steel. Like this, just a limestone or burnt lime, it totally helps the steels to get rid of the impurities on steel. Approximately, there are 2 tons of pin iron and 1 ton of coke and a half ton of limestone are required to produce 1 ton of steel. Like are there these process of manufacturing of steel? Steels. Well, steels are the alloys of iron and carbon, which is lesser than 2% of carbon, and contains iron, carbon, and silicon, manganese, sulfur, phosphorus, nickel at few percentage. Classifications of steels. There are 2 classifications: plain steel, plain carbon steels, and alloy steels. And the plain carbon steels are divided into 3 subtopics: low carbon or mild steel, or the medium carbon steel, or the high carbon steel. The low carbon steel or the mild steel, the percentage is 0.05 to 0.30 percentage of carbon, whereas in medium carbon steel it's 0.30 to 0.60 percentage of carbon, whereas even high carbon steel it's 0.60 to 2 percentage of carbon. And there are these subtopics are come under the plain carbon steels. And now the alloy steels. The alloy steels also divided into 2 parts, like low alloy steel and high alloy steels. Whereas in low alloy steels, the American Iron and Steel Institute and high strength of low alloy steel, and the short form of American Iron and Steel Institute AISI, and high strength and low alloy short form is HSLA steel. These come under low alloy steels, whereas compared to high alloy steels, there are tools, die steels, and cold and hot work, and HSS, and special purposes, tool steels, and stainless steels. Well, the plain carbon steel. In steel, the carbon exists as alloying element. Other constituents does not exceed 0.6% except manganese 1.65. Like the plain carbon steel contains, well, it's continuous. Even the process, even some of the compositions of a plain carbon steel, carbon it's 1.5 percentage, and manganese is 1.65 percentage, and silicon and sulfur, nickel, phosphorus, um, 0.4 to 0.6 percentage, and the remaining is iron. The properties, in plain carbon steel there are few properties. There are moderate price steels, and due to absence of alloys in large amount, and ductile in nature, they are soft and good machinability and formability, and they're available in form of sheet, strips, bar, and tube. Mm, Even for plain carbon steel, we have even applications, ball bearings and structural members and housing base plates. Like these applications are we generally know about this kind of application. Like these applications are mostly used in plain carbon steels. Well, it's low carbon steel, soft and weak, and good formability and weldability. Cannot be hardened by heat treatment easily. And this low carbon steel cannot be hardened by any heat treatment very easily. It cannot be hardened but of any heat treatment easily. But the strength can be improved by cold working process. But good ductility and least expensive one, and the microstructure contains ferrite and corpus perlite, purelite. There are few applications regarding low carbon steels. If you look even the automobile body and I-beams and channel and tin cans and pipelines and bridges. You can see here the microstructure of low carbon steel, like how it appears, even the automobile, the applications, the automobile body. You can see here applications of low carbon steel. Well, the next is the medium carbon steel. Mm, in medium carbon steel, the stronger than mild steel. Compared to mild steel, the medium carbon steel is very stronger, but it has very less ductile and it's a mechanical property. Can be slightly improved by heat and treat process. Like even the medium carbon steel can improve its mechanical property by treating with like treating the heat treatment process, but it has a poor machinability and easily welded and forged. Like you can see the microstructure of medium carbon steel over here, and even the applications of medium carbon steel, the railway tracks and wheels of locomotives, and gears and crankshafts, and forging dies and connecting rods. You can see the applications of pictures over here. And the next one is high carbon steel. High carbon steel, the strength and hardness of steel increase with percentage of carbon. Like the strength will increase with the percentage of the carbon simultaneously, and even the hardest and strongest of all the steels is the high carbon steel. Ductility and machinability is decreased, where resistant one, the capable of holding sharp cutting edges making tools. It has a great high strength and high hardness of steel which can increase with the carbon, and you can look here the microstructure of high carbon steel and some of the applications of high carbon steel cutting tools can razors and hacksaw blades, springs, punches and drills. These are the things which are general applications of high carbon steel. You can look the picture of spring, blade, and other pictures you can see here. However, it's alloy steel. As we had discussed earlier, alloy steels are two types: low alloy and high alloy steels. In order to improve the mechanical property of a plain carbon steels, alloys were added no matter what, and to refine the grain size, to improve the strength, the hardness and corrosion and resistance, the toughness and the machinability and cutting ability were resistance, electrical and magnetic property. So all are included in alloy steels, and in low alloy steel lesser than 5 percentage of alloy elements and greater than in whereas compared to high alloy steels greater than 5 percentage of alloy elements, and low alloy steels AISI steels and HSLA steels. Like we have said about AISI, the full form American Iron and Steel Institute Steels, and HSLA, High Steel and Low Alloy Steels. Like these come under of low alloy steels. Well, even high alloy steels, tools and die steels. For making tools and dies have high wear resistance, high hardenability, and good wear resistance. The classifications of tool steels uh, such as cold work tool steels and water hardening, oil and hardening, the air hardening, HCR and CR steels, hot work tool steels, and the chromium tool steels, and tungsten and molybdenum tool steels. These all are the steels which come under of high alloy steels. And generally, these high alloy steels are very good at what they are, and even it has a high hardenability and good weather resistance. Like it is a good making tools and dies. And high speed of tool steels is we have seen, and even in special purposes of tools, the shocking resistant tool steels. Like whenever our hands are wet, when we get kind of a shock, when it is a shock resistant tool steel, even the carbon tungsten tool steel and mold tool steels, like these all are come under the high alloy steels. Thank you.